So let's start with our second module. So today we are going to talk about what is the cluster configuration, what are the different techniques of loading the data, and we will quickly touch base with what is the kind of project that we will be working with. Topics for today, we'll quickly revise it. We'll look at what is a typical Hadoop cluster, look at the XML files, what are the different modes, what is a sample list in Hadoop, running one of the applications, looking at the MapReduce job, what are the data loading techniques, and what is the course, because after this you have to do a proof of concept. So we are going to show you a sample proof of concept which will be shared with you, which is going to be an end-to-end view of it. Okay, so this is what we are going to see in our module 2. You know what is the Hadoop core components, architecture, HDFS, Hadoop versus traditional system, name node versus secondary name node. You should know all of these things, right? So now let's move on. This is what would be the ideal Hadoop architecture. You will have a master in which you will have a name node and a job tracker both running on the same machine. If it is less than 10 nodes, that is a benchmark. If you have got more than 10 nodes, then the master will be one machine, and the master of HDFS will be one machine and the master of job tracker will be one machine, so that you don't get into a situation where both the daemon processes are trying to fight for the resources. So in an ideal architecture wherein you'll have more than 10 nodes, you'll have one machine for the name node, one machine for the job tracker, one machine for the secondary name node, and multiple machines which will have both the data node and the task tracker running. Why? Because of the data locality concept, wherein the processing happens on the node where the data is. Okay, hope that is very clear, friends. So now let's move on. Okay, Hussein was asking, why is a data node called a daemon? Because of the process, friend. The data is actually stored in the form of blocks. There are two daemon processes. That is what is called as data node. The daemon process is what makes it store the node, store the data, and to process the data. Okay. Anand was saying, so is the name node machine configuration different from client to client on a need basis? Typically the name node, the data, the job tracker and your secondary name node will always be high-end machines. They will have dual processors, a dual power supply, etc. And in one of the slides that is coming up, Anand, we will actually see a configuration also. So that will make it very clear to you. Okay, so it wouldn't be different for different clients, because once the cluster is created, all clients will connect to it. Perfect. So this is how the view would be. Whenever a client wants to talk about putting a file or getting a file, he will talk to the HDFS, wherein he'll talk to the name node, which will talk to the data nodes. And when he wants to process something, it will request the MapReduce to talk to the job tracker. We have seen it earlier, which will talk to the task trackers. Hope this is also clear, friends. This is the configuration slide that I was talking about. So in case if you are having a Hadoop cluster, this is from an actual production environment that we have taken. So the name node RAM will be about 64 GB, although it is not needed to be so high, but then this is from an actual production environment which had 130 node clusters. The hard disk is 1 terabyte. The processor is Xeon with 8 cores. Ethernet is 10 gigabytes per second. The operating system is CentOS, and it has got 2 power supplies. Secondary name node almost with the same configuration with a lesser amount of RAM. Okay, and data nodes have got 16 gigs. We were having a consideration, should I go for 8 gigs or 16 gigs? The difference was not major, whereas the performance benefit was tremendous, so we went for 16 gigs. The hard disk is 6 into 2 terabyte, that means every machine can hold about 12 terabyte. Okay, processor is with Xeon with 2 cores. I don't need an 8 core, only the name node needs 8 cores. The Ethernet speed was almost the same, and it has got a single power supply. We can't go for a dual power supply for 120 node cluster. Okay, so this is the actual production environment cluster. Okay, perfect. So now let's look at some of the customer use cases so that you would understand. I have already shown this to you, Hadoop powered by yesterday, wherein there's an alphabetical list of companies. You can see the link at the bottom too. So Facebook is using Hadoop to store the internal copies of the log and dimension data sources and use it as a source for reporting, analytics, and machine learning. Currently, they have got two major clusters, 8100 machine cluster with 8 cores and 12 petabytes raw storage. So every commodity nodes has got 8 core and 12 terabyte of storage. They use both streaming as well as Java APIs. So they were pioneers in developing a ecosystem component for Hadoop called as Hive. That is what is the SQL access on Hadoop. They were also pioneer in developing a NoSQL database called as Cassandra. This is only for your understanding. So now let's look at what all are the three modes in which Hadoop can be executed. Hadoop can be executed in a local mode where there is no JVM running. Everything is running on one JVM and it doesn't have a distributed file system. It has got a single file system because it's standalone, right? So everything is there on a single file system. Okay, so this is good for your development work, but then this is not as for testing of a production. What we have in our Cloudera distribution for Hadoop is a pseudo-distributed mode. That means your Hadoop daemons are running on one machine. It's a cluster simulation for us. And then in a fully distributed mode, you will have Hadoop different services running on different nodes. In 3 masters, you'll have one server running and the 2 slave daemons running on all the slave machines. Okay, so 3 separate modes in which how I can run my Hadoop friends. So now, little bit of hands-on. So we are going to go down to the terminal command. How do I open it? You can see the round circle over there. That's how I open up a terminal window. So let me go down to my Cloudera. It is asking me for a password. Let me put in the password once again, and at the top you should see the terminal window. I'm going to do that. So when I click on the terminal window, you see a hourglass coming and a terminal window being opened. So welcome, this is your first access. So for people who have not done the Hadoop and Linux hands-on, which was a part of module 1, please do that, friends. Okay? So we have already started with our module 2. We have started with our terminal window. Now, what are we seeing over here? This is repetition of what you have already seen in the hands-on, but I'll do it for you. The first thing I'm showing you is the files that is present on the Hadoop distributed file system. Remember, HDFS is always a virtual file system that is sitting on top of a physical file system. So this is the way how I can run that. Hadoop DFS space -ls and /. So let me go ahead and do that and show it to you. You will see 3 files, 3 folders. I will see a little bit more because I'm already working on it. So I'll say Hadoop DFS space -ls space /. So Hadoop DFS is must in case if you want to do anything on the Hadoop file system. DFS or FS, both of them are synonymous. Then minus and then the Linux command, and this is from where I want to check it. When I press enter, I will see a lot of files, but you don't worry about it. You would see only 3 folders, guys, because you have not started working with it. Okay? I did the first command, that is for listing the contents of the HDFS, so all of you would be able to see this too. Okay? Thank you. Then the next thing that we are seeing over there is if I want to go down to the bin directory and see what all are the start scripts, I can do that also. Let me show this to you. So now now for me to go down to that particular folder, where is Hadoop? Hadoop is installed in /usr/lib/hadoop 0.20. That means the release that you are working on is 0.20. There would be no change till 1.2. In 2.0, the architecture is different, and we will see that architecture in our module 9. So let me go down to this particular folder, /user. I'm in the Cloudera user. So as most of you would know, when I do a pwd, it will tell me where I am. Okay, I'm in home Cloudera, but I need to go down to user lib, etc. Hussein was saying, can you please tell me, is this Cloudera terminal accessing HDFS remotely? No, my dear friend Hussein, I have got the VM running on my machine. I'm not showing you a remote client. This is running on my machine, friend. Okay? So now let me go ahead and go to the folder where Hadoop is installed, /usr/lib/Hadoop, okay, and bin folder. Okay, and then when I do a plain ls, you see here it gives me all the just one sec, giving me all the ss files that is needed. Okay, so this was the terminal commands that we had. Let's get down to the next one. Now when we look at the Hadoop configuration files, Avinash, are you clear on this, how to set this up locally? That's how everybody has done it. People who don't have downloaded, they haven't done it, but others have downloaded the CDS3, and the document tells you how to set it up, Avinash. Okay, fantastic. So the important files that we have is a file called as hadoop-env.sh, which will contain all the environment variables for you to run. Core-site.xml will contain the configuration settings, which is very crucial to both HDFS and MapReduce. hdfs-site.xml, which will have all the configuration values for your HDFS daemons. Which are the 3 HDFS daemons? Data node, name node, and secondary name node. mapred-site.xml, which will have the configuration settings for your MapReduce daemons, that is job tracker and task tracker. And then two very crucial file, a masters file in which you will enter the secondary name node location. Okay, the secondary name node would be there in a file called as masters, and you will have your slaves that is entered in your all the slave IPs will be entered in your slaves file. Okay, so there are crucially 6 XML files that is there in a cluster. The first one will have your hadoop-env.sh, will have your Java home. The core-site will have the locations for all the HDFS for the thing that is common to both your HDFS and your MapReduce. Your HDFS-site will be only for HDFS. Your MapRed will be only for your job tracker and task tracker. Masters will contain the IP of a secondary name node, and slaves will contain the IP of the data node and the task tracker. Okay, so these are the configuration files that we have, friends. So let me go back. Gagan was saying, out of these configuration files, do we need to have it replicated on all the nodes? Yes, Gagan, all of this configuration files should be there on all of the client as well as the slaves and all the 3 masters. Okay, perfect. So see here, in case if you want to see in CDH3 these files, let me go down to the conf folder and then list it out for you. So let me do a clear so that this goes away. And let me do cd space .. cd space conf, cd space conf, and let me do a ls. You see over here, you will have your hadoop-env.sh, you will have your core-site.xml, you will have your mapred-site.xml, you will have your HDFS-site.xml, you will have a masters file, and you will have a slaves file. Okay, all of the files are available for you, friends. Perfect. So these are the 3 XML files that is mandatory: the core, the HDFS, and MapReduce. Okay, hope it is clear for you guys. All of you, you are very clear with what's happening till now, right? Any questions, please do not hesitate. Now we are going to go down to each of these individual XML files and tell you what each file will contain. The core-site.xml will contain the IP of your name node. Okay, fs.default.name is the property key whose value will be the name node IP. So why am I saying hdfs://localhost? The reason I'm saying hdfs://localhost is because in our current environment, everything is running on one machine. So that's the reason why we are specifying our localhost. Sarvana was saying, if I install Hadoop infrastructure in Windows, I don't need to understand Linux command lines, correct? Hey, I'm sorry to say, if you are going to work on Hadoop, you have to know Linux commands. You will be running your Linux commands on your Windows command prompt, friend. Okay, Sarvana? Even for HD Insight, the commands that you have to know is Linux, friend. Okay, because primary is Linux only, friend. Okay. Then in your hdfs-site.xml, we will specify the replication. Any idea why we are having the value as 1 here, friends? I thought I said the default is 3, right? So why are we having as a replication only as 1 here? Anybody, friends? Configurable, good. Because we have only one slave. That's right, Jesse. That's right, Vishal. Localhost 1. Because we are running a pseudo cluster. Very correct, Gagan. Okay? Yeah, good, Ambarish. It's a pseudo cluster. Single node. That's right, Charu. Exactly correct. We have got only one node. Okay? That's the reason. Now, in your hdfs-site.xml, you will specify where your data.dir is going to be. So data.dir, whatever values you are going to have over there, this will be the list of directories where the data node stores the blocks. This is at the individual node level. Each block is stored in only one of the directories that is given if you are writing more than one directory. So dfs.data.dir will contain the block details wherever the actual locations where the blocks are stored. Then your checkpoint.dir will contain the list of directories where the secondary name node copies the checkpoints. So Srinivas, you're there or you're going to sleep? So Srinivas, you had asked me a question, how can we put something into a SAN, right? So this is where it is. So your fs.checkpoint.dir will contain the list of directories where the secondary name node stores the checkpoints. It stores a copy of the checkpoint in each directory in the list. So that is what is important over here, friends. So the data.dir is stored only in one location, whereas your checkpoint.dir is there in each directory in the location. So you can point it to your SAN also. So what will be stored over there? Only the fs image and the edits file. Okay. So these are the two values that is there in your hdfs-site.xml. Your mapred-site.xml will contain the location of your MapReduce master, that is your job tracker. So we specify this localhost 8021. So internal communication happens through 8021 and your 8020 port number, which is for name node. In addition to that, in your mapred-site.xml, we will also specify the local dir and the system dir. The local dir is a place where the intermediate data for your jobs is done. So anything that is happening after the mapper, before it goes to the reducer, is stored in this particular directory. Okay? Hey, checkpoint is a secondary name node, Girish. Checkpoint.dir is nothing but the secondary name node, which is like a backup node, right? Then you will have a system.dir location, which is a directory that is relative to the fs.default.name, where the shared files are stored during the job run. Okay? So your mapred.system.dir will contain your shared file location, that is your reference data or your lookup data. And local.dir is the folder where the MapReduce jobs are stored. Remember earlier when we were talking about MapReduce, I said that you don't need to have, if there are 1 million records, you don't need 1 million map runs. You will specify the number of the mapper and the reducer slots. This is where that number is specified. Okay, I'll show it to you later on. This is where it is. This tells you the number of map tasks that can be run on any task tracker at one point of time. This is per processor. Okay, if I have got i7, I would have got 8 processors. So 8 into 2, 16 map slots will be available for me in one machine. If I have got 100 machines, I will have 1600 map slots available. So you can see how with the increase in the number of nodes, your number of slots become high. Hey Vishal, very simple. I gave you an example, Vishal. Your intermediate output from the mapper to the reducer, whatever output is there, that is what will be stored over here. Once the job finishes, the data is gone. Any reference data that has to be used in your mapper or reducer, like your lookup data, that is stored in this directory and it is not deleted when the job runs. Okay? So that is the difference between your local and system there. Hope it is clear for you, Vishal. So this is what Vishal had asked. Let me put it in the chat window for everybody. Yeah, you're welcome, Vishal. And then let me show you. I've got 8 processors. I've got i7. So if I go down to my properties of my computer, if I go down to my device manager, and you see I've got Windows 7 Home Premium, Service Pack 1. And if I go down to my processors, I have got an i7 model as what you can see, and by default there will be 8 processors that will be there. See over here, I'll have 8 processors. If it is a dual core or something, it will have 2 processors. If it is quad core, it will have again 8 processors. Okay, so this all depends upon the configuration of your system. Okay, so but then you will have 2 per processor. And that is what is there in mapred-site.xml. Friends, clear on this until now? Are we clear on what should be there in core, what should be there in HDFS, and what should be there in mapred? Can I get a confirmation, please? If anybody is having a doubt, please ask me, friends. Or else you can definitely go through this and then again ask me next week also. I'm fine with that. But then the concept should be very clear. Thanks, Anne. Thanks, Nanda. Thanks, Abdul. Thanks, friends. So now, do you think these are the only properties that we have? Okay, absolutely not. Okay, hi, thanks Priyank, thanks Charo. So we will have 16 for my PC, exactly Gagan. 16 map slot and 16 reducer slot. Rajiv was saying about what is the system and the local and the system. My dear friend, the local will contain where the intermediate data would be stored, which is deleted after the job runs, and the system will contain the shared file data. Anything that is reference data or lookup data will be there in system, which is not deleted after a job is run. So Avinash was saying, how many processors do we need minimum? Yes, minimum 2 cores is needed. That is what is happening nowadays. If you look at this links, these are all hyperlinks for you. If you look at that, it will open up a page where it will show you all the other default properties. If you don't write a property, it will take it up from the default. Okay, so you can look at these things. Let me click at core-default. I thought I clicked on it. Let me open this. There we go. So you will see that it has got lots of things here. What is the temp directory? It will tell you what is the name, what is the value, and on the right hand side it is going to give you a description also. Okay, if you scroll down, you will see it has indeed got a lot of values. I told you that the default is 64 MB, right? So let me go ahead and show that to you. There it is. The fs.s3.block size is 67108864 because it is 1024 MB, right? So this is actually 64 MB. Okay, 64 into 1024 will give you this particular value. Fine. So this is just to show you what all are the different properties that we have. Now, if you look at the slaves and the masters, we know what these files are for. The 2 files that is used by the startup and the shutdown commands are the slaves and the masters. Slaves will contain the list of all the hosts 1 per line. That will be for the data node and the task tracker. And masters will contain the list of your secondary name node. Ideally, it will only be 1. Okay. Your Hadoop-env.sh will have the value of your Java home. Okay, so this file gives you a way to provide custom parameters for each of the servers. Your Hadoop-env.sh is looked by all the necessary configuration files, and you can also specify what is the heap size of your servers by an entry over here. Okay. So this file is very crucial. Ideally, you will have the Java home, and if you want to set different heap sizes for your daemons, you can tweak over there. This is a very basic requirement, but then if you want it to be using for a whole day, the heap size should be reasonably. The default heap size is 1000 MB or 1 GB. Okay. You can change the heap size to 128 or 512 also, depending upon your requirement, friends. Hey, Anand was saying, what is the heap size? Heap size is the size of the JVM. Remember when we say name node, data node, secondary name node, job tracker, task tracker, these are all nothing but JVMs that runs with a default 1 GB space. If you want to tweak it, you can tweak it from this particular file. Jissi was saying, is this a value, the minimum or the maximum? My dear friend, by default it is 1000 MB, 1 TB. Here we are showing you what is the minimum size that we require, Jissi. Okay? Perfect. So now, if you go down to the browser, there are various shortcuts which will show you what is the shortcut of your name node, what is the shortcut of your job tracker, task tracker, and the data block scanner report. So I'm going to show this to you to see how it would work. Let me go back to my VM. Here, just one sec. There we go. It has thrown me out, so let me put in my username. And if I go down to my browser, besides the terminal window, there is a browser. If I click on that browser, your name node is kept as favorites. Let the browser come up. There we go. So you see here, name node status is the favorite, job tracker is also there. So if I click on that name node status, you know that the name node is working on this particular location. And if I click on browse the file system, all the files that we have created would be there in a separate folder or as a file over here. Later on, you will also be doing this. Don't worry. Okay, so this is what is the name node status. This is something similar to Hadoop -dfs space -ls space / right? Whatever I saw on the command window, this is the same thing what you're seeing. So let me run that again real quick. There we go. Okay, so what all are shown to you over here, the same thing is what will be shown to you in the browser also. Okay. Now let me go down. So Avinash was saying, please show it again. See, when you start with your browser, click on this name node status. You will see the name node status. It will tell you how many files I have. You might have 24 or 25 files only because you haven't done anything. I have got 111 blocks. Okay, how many live nodes, dead nodes are there, and if I click on the browse the file system, it will show me that particular file system for me. Okay, so this is like a normal file system, folks. So that is what is your name node status. Similarly, you can get your job tracker status also by clicking on this. It will tell me the job tracker status. It will tell me how many running maps are there, reduced maps are there, then how many nodes are there. Okay. And see, this is the map task capacity and the reduced task capacity as 2 and 2. Remember I told you earlier something about a queue. So the default queue is the queue over here. If you scroll down and if you go down to the job tracker history, all the old jobs that I have run, what is a job? We'll see it next week. Don't worry. We'll be covering that for sure. So all the jobs that I have run over here, which will be there in the job tracker history. See here. I have run a couple of jobs and all of those jobs are shown to you in the job tracker history, friends. Okay, and if you go down to your, let me click on this once again. Yeah, so if you go down to your 50060, you will see a task tracker. Remember, these are there for every machine. So let me see a task tracker. There we go. So task tracker is there for every machine. Job tracker is the master. Okay, Anand was saying blacklisted nodes and excluded nodes. Blacklisted nodes are nodes from where there has been a lot of rejections that is coming. Okay, see, let's scroll down. I don't see the blacklisted nodes over here. Anand, I think you are running a wrong VM. Okay, blacklisted nodes and excluded nodes will come only in Gen 2. Okay, so these are the only things what I see. You need your CDH3 Anand. Okay. You saw it in my web browser list. Okay. Where did you see it in the web browser list? Okay, let me go down to the job tracker. It was not there in the job tracker, nor was it in my, it shows me live nodes and dead nodes and decommissioned nodes. It was there on the top. Just one sec, let me scroll up. There it is. If I look at the job tracker status. Okay, you're talking about this one. Okay, got it. The same thing. So this is, when you're trying to do an analysis, got it, Avinash. So when you do an analysis, at that time, if any of the nodes are not giving you an answer, even after repeated request, they can be blacklisted, okay, and they can be excluded also. There it is. I got it, Anand. Sure. So we saw what are the task tracker, and now let's see the last one, that is 50075, which is a block scanner report. You see I have got 111 blocks, whereas you would have only one block right now, friends. Okay? Thanks. So we'll pause over here. So this is where we are. We'll do one more slide so that we are finished with our 30 pages of this. We are well on time. Don't worry as far as the course is concerned. But non-Java friends, you have got 1 week wherein you can cover up the complete Java part of it. So the Java Essentials is must. And next week, please read chapter number 1, 2, 3 of the Hadoop Definitive Guide. That will make your understanding very clear. And we're going to start with finish up this and then start with MapReduce next week. Okay? So now, interesting thing. Come on, guys. Let's look at a couple of Annie's questions before we wrap it up for today. Which of the file is used to specify the heap size? I just discussed it right now. The heap size are always specified in good. Rishikesh was asking any special module of Java you want to focus. I'm talking about core Java. You just need to know your core Java. That's it. Okay. Hey, we are talking about the heap size. It wouldn't be there in my hdfs-site. hdfs-site will have my data directory location and my checkpoint directory location. Two people are given a wrong answer. It is not in hdfs-site. It is there in Hadoop-env as correctly mentioned by Anand, Ambarish, Charu, and Gagan. So the answer to this is actually going to be Hadoop-env.sh because that is the place where the daemons are stored. Okay, the env.xml file. That's correct, Anne. That was mentioned by Abdul and Rajib also. The Hadoop-site will have the replication, will have the data.dir and checkpoint.dir locations, directory locations. There we go. So is it necessary to define all the properties in the core-site? You saw there are so many properties, but then do we have to define all the properties, or will it take the default if we do not define it? Very good. But obviously, because I showed you a file wherein in core-site I had only one, so we don't have to define the properties. No, somebody says true. We don't have to define the properties. Okay, it'll take up, if you don't define it, it'll take up the default. Okay, so please remember, you don't have to define the properties. It'll take up the default, friends. Okay, so good. The answer is false. Detailed answer is after the next question. So let's look at the next question. Another 2 minutes and then we are done, guys. Don't worry. The standalone mode uses the default configuration. Yes, because in a standalone mode, you will not write any XML file and it will always take up the default values. Okay, good. Most of you are getting it correct. Nanda, Priyank, and Vikas, Gagan. Good. So yes, the standalone mode will take up the default values. So in a standalone mode, Hadoop configuration runs with the default configuration empty XML files. If properties are not defined in the configuration files, Hadoop will run it by taking up the corresponding default values. Thanks Deepika, thanks Rishikesh. Absolutely correct. Okay, that's it. So I'm going to stop at slide number 35. We will again meet up next week. Like always, please put in your feedback. I really appreciate that. And I hope I have catered to some of your requests yesterday. Okay, I tried my best. Okay, so we will again catch up next week, friends. Slide number 35 is where we are stopping. Yes, friend. We'll meet up on next Saturday at the same time. So thanks, everybody. Thanks, Anand. Please put in your feedback. I really appreciate that. Thank you. Thanks, Abdul. Abdul says the course is clear. Thank you so much, Abdul. Please put in your feedback. It is valuable. Thank you. Enjoy the rest of the week, guys. Thanks. Sure, Ajib, I will share you my details. Thank you. Have a fantastic week and have a good night for our US colleagues, and have a great day for our Indian friends. Thank you. Thanks, Rishikesh. You too. So Priyank was saying, wish you got increment on time, everybody. Okay, if everyone is in increment week. Okay, good. Yeah, thanks everybody. Thanks Jesse. Thanks Gagan. Bye everybody. Thanks Abdul. Thanks Priya. Thanks Abhishek, Vishal, Sandeep, Sarvana, Girish. Thanks everybody. So this is Venkat signing off. We will again meet up on next Saturday, same time. Bye-bye from Venkat after module 2.